Always when you look at an FRQ, it's very important to identify the key information. And the first fact that's really important is when you're looking at the table to recognize that the output is a rate. It's what, gigaliters per day? So understanding that's a rate. Also knowing that this function is differentiable. Other important facts is that it's a closed interval from 0 to 30. And then they give you 1 point on the function. When the time is 30 days, there's 125 gallons in the tank. Now that you've identified the important information, in answering question A, key phrase right there is tangent line. So that means I need a slope and a point at t equals 30. Well, we're given the point 30, 125, and when I look at the table, I know that the slope when t is 30 is 0.5. So immediately we can write a linear equation, y minus 125 is equal to 0.5 times x minus 30. And we are asked to use this equation to approximate the gigaliters at 32 days. So then we would have minus 125 is equal to 0.5 times 32 minus 30. Now all of this math should be pretty straightforward since it is without a calculator. And half of 32 is 16. I guess I could have just done 2, and then half of 2 is 1, right? That would be much easier. So let's do that. Add 125, and the answer is 126. Now for this problem, you got 1 point for the correct answer. Okay, now moving along to part 2 of this. Now in part 2, you're asked to use a left Riemann sum with 3 subintervals. Okay, and we're approximating the value of the integral of 0 to 30 of w prime t. Okay, we're looking at my table of data, so I'm going to start from the left. So that means my first output will be 0.6, and then the change in x is going to be from 0 to 10, so 10. Now my next interval is going to be from 10 to 22, which is a change in x of 12, and the output is going to be 0.7. And then the last change in x is going to be 8, and the output would be 1. And then when I do the mathematics and add that all up, I get 22.4. Now, what does that 22.4 represent? Well, we're finding the integral of a rate of change, so this would be the gallons. Okay. Now, the second part of the question says, use this approximation to estimate the volume of water in gigaliters. Oh, I'm sorry, this is not gallons. Gigaliters. Sorry, folks. Okay. In gigaliters in the reservoir at time t equals 0. Well, really, this is a fundamental theorem, right? Because really, we're looking at, well, when you take an integral of the rate of change, then we know, according to the fundamental theorem, that would be w of 30 minus w of 0. And we just found the approximation for the integral from 0 to 30 to be 22.4. And we're told that at W30, we have 125 gigaliters. And we want to find the approximate number of gigaliters at W of 0. So when I do the mathematics, then what I end up with at 0, we have 102.6 gigaliters in the tank. Great. Now for this problem, you get 1 point for setting up the left Riemann sum. You get 1 point for getting the correct approximation, and then you get 1 point for getting the correct answer at W of 0. Okay, so part 3 now. We have to explain why there must be at least one time t other than 10 such that W prime t is equal to 0.7 gigaliters per day. Well, we're told at the beginning of this problem that this is a twice differentiable function. Well, we know that if a function is differentiable, then it must be continuous. So, if this function is differentiable, therefore, it must be continuous. Now, looking at the data, we can see that we're increasing, and then from time 22 days to 30 days, we're actually decreasing. And according to the intermediate value theorem, if a function is continuous, whoops, I don't know why I just wrote W. Let me erase that there. Okay, here we go. According to the whoops, forgot to get my pen back on. Now we got it going. According to the intermediate theorem, if a function is continuous, then we can guarantee that this value of 0.7 must occur. Then we can guarantee that there must be at least one time t such that t equals 0.7 since t is less than or equal to 1 but greater or equal to 0.5 on the interval (22 to 30). Okay, so the intermediate value theorem here comes in quite handy. Now let's move on. Now part 4, we're given a new function, and this function represents the area. Okay, so 0.3 w to the 2/3, and we're asked to find the instantaneous rate of change of the area with respect to t. Okay, little implicit differentiation going on here. So the change in area in respect to t. So it's a power rule, so I'm going to bring the 2/3 in the front, 0.3 w, and then 2/3 minus 1 is negative 1/3. Now the w, remember you have to go dw in respect to t, because everything is in respect to t. Now I'll clean this up a little bit, and we end up with, let's see, 0.6 divided by 3 is 0.2, right? And then with the negative exponent is in the denominator, w to the 1/3, and it's dw dt. Now we are asked to find then, at time when t is equal to 30, then what would be this value? Okay, well, we know that when t is equal to 30, that the number, whoops, that the amount of gallons in the water was, what was that number again? Oh yeah, 125. Okay, so if I substitute these values, I get 0.2 to the 3rd root of 125 multiplied by, at t equals 3, the dw dt is 0.5. Okay, and when I do the mathematics, I end up with 0.02. So for this problem, you get 2 points for taking the derivative in respect to t properly, and then you get 1 point for getting the value of 0.02. And I forgot to mention, on the previous part, you got 2 points if your explanation was accurate.